Welcome friends, I am SD Farande and today we continue our last session on the unit of design of shaft. Today we see the design criteria for shaft and shaft subjected to twisting moment. These points we cover today. Design of shaft means design criteria for shaft. The shafts may be designed on the basis of strength and rigidity and stiffness. The first criteria of the shaft design is the strength and second one is the rigidity and stiffness criteria. In designing shafts and on the basis of strength, the following cases may be considered. Shafts subjected to twisting moment means torque only. Second is the shaft subjected to bending moment only. Third is the shaft subjected to combined twisting and bending moment. And last one is the shaft subjected to axial loads in addition to combined torsional and bending loads. म्हणजे या ठिकाणी पहिला जो आहे स्ट्रेंथ बेसिस वरती आहे तो आपण बघणार आहे. ट्विस्टिंग मुवमेंटला जो शाफ्ट आहे तो बघणार आहे. दुसऱ्यामध्ये बेंडिंग मुवमेंट. तिसरा जो आहे पहिल्या आणि दुसऱ्याचं कॉम्बिनेशन म्हणजेच ट्विस्टिंग ॲज वेल ॲज बेंडिंग. आणि जो शेवटचा आहे या तिन्हीचं कॉम्बिनेशन आहे. लक्षात आलं. आणि त्यात ॲडिशन काय असणार आहे, ॲक्सियल लोड असणार आहे. शाफ्ट सब्जेक्टेड टू ट्विस्टिंग मुवमेंट ओनली. व्हेन द शाफ्ट is subjected to twisting moment means what, torque only, then the diameter of the shaft may be obtained by using the torsion equation. We know that the torsion equation T by J is equals to tau by R. In that T is the twisting moment means torque acting upon the shaft, J is the polar moment of inertia of the shaft about the axis of rotation. त्याच्या ॲक्सिस ऑफ रोटेशनला जो पोलर मुवमेंट ऑफ इनर्शिया असणार आहे तो असणार आहे. स्ट्रेंथ ऑफ मटेरियल मध्ये हे इक्वेशन आपण बघितलेलं आहे. टाऊ इज द टॉर्शनल शियर स्ट्रेस. टाऊ मीन्स व्हॉट, टॉर्शनल शियर स्ट्रेस. अँड आर इज द डिस्टन्स फ्रॉम द न्यूट्रल ॲक्सिस टू द आउटर मोस्ट फायबर. म्हणजे सेंट्रलचा जो ॲक्सिस आहे जो न्यूट्रल असणार आहे, ज्या ठिकाणी स्ट्रेसेस झिरो असणार आहेत, तिथून जो हायर स्ट्रेसेसचा फायबर असणार आहे म्हणजे आउटर मोस्ट फायबर असणार आहे तिथपर्यंत डिस्टन्स म्हणजे किती असणार आहे, डायमीटरच्या हाफ म्हणजेच डी बाय 2, वेअर डी इज द डायमीटर ऑफ शाफ्ट. फॉर राऊंड सॉलिड शाफ्ट, सुरुवातीला आपण बघितले शाफ्टचे दोन टाईप आहेत, एक आहे सॉलिड आणि दुसरा आहे हॉलो. पहिल्यांदा सॉलिड शाफ्ट कन्सिडर करणार आहे आपण. J is equals to pi by 32 into d raised to 4. J is the polar moment of inertia. The equation 1 may now be written as, means this equation is written as, converted T upon pi by 32 into d raised to 4 into tau divided by d by 2. Means this value is putting in this equation 1. We get T upon pi by 32 d raised to 4 is equals to tau upon d by 2. Convert it and get the twisting moment T is equals to pi by 16 into tau into d cube. From this equation we may determine the diameter of the round shaft. For hollow shaft, polar moment of inertia, hollow shaft having two dimensions, outer dimension and inner dimension. This is only difference in the solid and hollow shaft. And for hollow shaft, DO is the outside diameter, DI is the inside diameter, and R is the DO by 2. In solid shaft D by 2, hollow shaft DO by 2. The equation may be written as, after writing this equation we get T is equals to pi by 16 tau into DO raised to 4 minus DI raised to 4 divided by DO. This is equation number 2. Let K is equals to ratio of inside diameter and outside diameter of the shaft, means di by do is known as K. Now the above equation is written as T is equals to where is the di by do? Put there k, pi by 16 into tau into do raised to 4 upon do into bracket 1 minus di by do raised to 4 bracket completed. Put di by do as a k. This is equation number 3. From equation 2 or 3, the outside and inside diameter of hollow shaft may be determined, means do and di. It may be noted that when the hollow shaft is to be made equal in strength to a solid shaft, the twisting moment of both the shaft must be same. In other words, for the same material of both the shafts. Hence, T is equals to pi by 16 into tau into do raised to 4 minus di raised to 4 upon do is equals to pi by 16 tau into d cube. आता हे काय केलं आहे, हॉलो शाफ्ट आणि सॉलिड शाफ्टचा ट्विस्टिंग मोमेंट सेम आहे. कधी असणार आहे सेम? ज्यावेळी हॉलो शाफ्ट आणि सॉलिड शाफ्टचा स्ट्रेंथ इक्वल असेल त्यावेळी, बरोबर. त्यामुळे आपण इक्वल घेतलं. त्या इक्वेशनवरून आपण सिम्प्लिफाय करून do cube into bracket 1 minus k raised to 4 is equals to d cube. Second note is that the twisting moment T may be obtained by using the below relation. We know that the power transmitted in watt P is equals to 2 pi n T upon 60. Means T is the P into 60 upon 2 pi n. This equation we seen in the power transmission theory of machine, where capital T twisting moment Newton meter, n is the speed of the shaft in RPM. Third one is the, in case of belt drives, the twisting moment T is given by T is equals to T1 minus T2. T1 is the tension in tight side, T2 is the tension in slack side. In case of belt drives, this is the torque T, and R is the radius of the pulley. One problem is here. Let's understand one problem. A solid shaft is transmitting 1 megawatt at 240 rpm. Determine the diameter of the shaft if the maximum torque transmitted exceeds the mean torque by 20%. Take the maximum allowable stress as 60 megapascal. Write down first. Given P is given 1 megawatt 1 into 10 raised to 6 watt. RPM is given 240 rpm. Tau max is given 1.2 T mean, म्हणजे maximum torque is given, and shear stress 60 megapascal, 60 Newton per mm square. Let small d is the diameter of the shaft. We know that mean torque transmitted by the shaft T mean P into 60 divided by 2 pi n. Put the values. P is 1 into 10 raised to 6, n is a 240. Get it? 39785. 784 Newton meter. T mean is that much. Maximum torque transmitted T max is equals to 1.2 times of T mean. Put the values of T mean, get T max. After that, we know that maximum torque transmitted T is equals to pi by 16 into tau into d cube. Put the values of T, maximum T, and get the small d is the near about 160 mm. This is the problem on shaft. Okay. Thank you friends.